Hi everyone, I'm Libby with the ASU Department of Economics Tutoring Center, and today I'll be going over some regression analysis examples or approaches you would take. If you have a TI-84 calculator, you can use some matrix algebra to calculate these statistical findings. So the first thing I did is listed out some given data. So we have our y values, which are dependent variables, and then we have values for x1 and x2, which are our independent variables. So a pretty typical question in regression will be to find the coefficients for each x1 and x2, and that shows the relationship they have with y. So when finding your coefficients, these are the 3 steps that you will need to do with your calculator. So the first step will be to create an X matrix, and it's helpful to write out the X matrix before you enter it into the calculator. So if you were to do this, the X matrix is equal to the values for your x1, the values for your x2, and a column of ones that you'll be including before these x1 and x2 values. In this column of ones will account for the coefficient value that you'll need. So when you enter this into your calculator, you should denote which matrix you're storing it in. So that's why I have here, if I were to enter this into my TI-84 calculator, I would create a new matrix and label it matrix A, and enter in these values for your coefficient x1 and x2. And so that all demonstrates your x1 matrix. Then you go to step 2, which is creating a y matrix, and I denoted it as being in matrix B. And when you create your y matrix, it's very simple. You just input the data that you're given for y. And then the next step is actually calculating the coefficients. So this is a regression formula that is given to you, or you should just memorize because you'll probably be using it a lot. So it's the matrix X, so in our case it's matrix A, transpose, which is a demand you can do in your calculator. So X transpose X, the quantity inversed, multiplied by the quantity X transpose Y. And in our case, Y is matrix B, so you'd enter in matrix B. In this, if you hit enter, this will give us another matrix, a 3x1 matrix, and it'll give you 3 values. The first one will be your coefficient, or your constant, and the second one will be your coefficient for x1 that is labeled as beta 1. And your second one will, or your third one will be your coefficient for your x2 value or beta 2. And what I would do then is store these values into your matrix C, because you'll likely need them to do future calculations. So now we'll be using our TI-84 calculator to demonstrate what we just went over on the board. So the first step will be creating our X matrix, and if you remember, this is the one with the column of ones and then our values for x1 and x2. So you'll hit second, and then right here in very small blue letters you can see the word matrix. And then you'll scroll over to edit, and now we can create a new matrix, and this will be our matrix A. We need a 5x3. So a 5x3 matrix, and we need our first columns to be all values of 1. And then the second column will be our x1 values, which is 22, -16, 6, 6, and 1. And then this second column, or this third column rather, is 7, 5, 71, 72, and 1. And I just realized I accidentally entered a positive 1 instead of negative 1, so we're just going to go back and correct that as a negative 1. So now this is our matrix A, or the X matrix. And now we'll be creating our matrix Y. So we go back into second matrix and go to Edit, and I'm going to create my matrix Y in the B matrix, and this is a 5 by 1. So the column will consist of our Y values, the first one being 146, 193, 131, 199, and 168. Okay, so now we'll be creating our X transpose X inverse, X transpose Y formula using those matrices we just created. So use your parentheses, go to second matrix, and you grab your X matrix, so that's A. So you have X, second matrix. If you scroll over to math, you can do the transpose command, X transpose X, and that whole quantity is inverse, multiplied by the quantity X, transpose again. And this time when we go into the matrix formula, we'll grab our Y matrix. So that's X transpose X inverse times X transpose Y. And if you hit enter, you'll get a new matrix, and these are your coefficients. So this first one is your constant. This second one is your beta 1 or x1 coefficient. And this third one is your x2 or beta 2. And if you'd like to store these for future calculations, you can use the store command, or STO. And if you hit store and go to second matrix, you can store these values in your C matrix. And now you have your coefficients stored. So if we use our calculator like I just showed you, using this data as your input, then the values you should be getting for your coefficients are as follows. So for beta naught, or your constant, it should be 170.639. For beta 1, you should get negative 1.22. And for beta 2, you should get 0.029. So using these answers, just to interpret them in terms of what they mean, we have the formula y equals the coefficient for beta 1, which is negative 1.22 times x1, and then plus the coefficient for x2, 0.029 x2, plus the constant, which is 170.64. So the purpose of regression is to develop a linear model, and so using these values, our betas, we're able to add in the weights they have on x1, x2, and then the overall function's constant value, which is 170. And so with this formula, you're able to sub in a value for x1 and x2 and find the output or the dependent variable.